Yellow, everybody. Welcome back to Lesson 10A-3B. Really, it's Chapter 11, Lesson 6 in the textbook. Volume of a circular prism. Circular prism. Why on earth would we call that circular prism? I guess we could call that cylinder. More on that as we go through. Pause your video. Come on back when you're ready. So for today, ladies and gents, here is where we are at. I will find the volume of a circular prism. How about we just call that cylinder, shall we? But think about where we've been. Started with one-dimensional measurement, moved up to two-dimensional measurement, and then yesterday and today, we've gotten into three-dimensional volume, a measurement of the space filling a three-dimensional figure. Now, we did a little bit of length, width, and height, so let's crank it up a notch, shall we? Now, notice eventually we're going to move into composite figures with cylinders. I want you to think about if you needed a certain amount of paper towels, would we need to add or subtract that interior cylinder? Think about that. All right, so why did Mr. Callan start off by calling this a circular prism? I want you to look at those two three-dimensional figures, the red figure and the yellow figure, and look at how they are similar to begin with. If you simply, as we did the other day, if you found the first layer, which we could call that the area of the base, and then you stacked those on top of each other, in other words, multiply by the height, you could find the total volume that fills that red figure. Now, guess what? We could do the same thing here, where we could find the area of that base, and then we could stack those h units tall. So far, they're exactly identical. Find the area of the base and stack them up. Now, where do we go with that in the previous lesson? Well, to find that area of the base, we would need to multiply the length and the width, and then, of course, stack it up. Okay, so what's the area of this base? Because the stacking up, the height is oh, wait a second. The area of this base is a circle. So if we found pi and multiplied pi times the radius times another radius, or in other words, a radius squared, just as we found the area of the base and multiplied it by the height, we could find the area of the base and multiply by the height. It all comes from the same equation, but naturally the key difference is what is the shape of the base of that, well, prism, I guess you could say, but prism I think would be more for the left figure than the right. So I wanted to show you briefly where that came from. Find the area of the base and then stack it on top of each other, either up or down. I don't care which direction you go. What is the area of that base? Well, that base would be a circle. Pi times radius squared times the height. Please remember, if you are ever given a diameter, you would have to take the diameter and cut it up into two parts in order to get one single radius. Okay, a couple examples here. Notice in example 1, we have a radius given, so no need to change 3. Multiply pi times 3 times another 3 times 5. Folks, it is perfectly all right with me if instead of this, you write pi times 3 squared times pi times 5, excuse me. I tell you what, I don't mind at all writing pi times 3 times 3 times 5, because when I do that, you see 1, 2, 3 dimensions, just verifying that you're finding a three-dimensional volume. Grabbing your calculator, multiplying pi times 3 times 3 times 5, rounding it to the nearest hundredths place. There is no feet or centimeters, so we'll just call that cubic units for a final answer of approximately 141 and 37 hundredths. Onward to number 2, example 2. Now take a look at this. I don't care if that cylinder is on its side. I don't care if it's upside down. It doesn't matter to me. You better be able to look at a cylinder and identify what the radius is going to be. Therefore, if you have to turn your paper, then go ahead and do so. We see on either of the bases, top or bottom, the radius of the circular base is going to be 6. So we have pi times 6 times 6, and then we stack it 7 units tall. Pi times 6 squared, again, if you would prefer, you're welcome to write pi times 6 squared times 7, but I kind of like it this way because then you verify that you have not 1, not 2, but a 3-dimensional measurement. Go ahead and multiply pi times 6 times 6 times 7, you get approximately 791 and 68 hundredths cubic units. So folks, it doesn't matter how the shape is started, you still need to be able to look at a cylinder as a circular prism, which is kind of a weird thing to say, in which you would take one circle and stack it up. And if you have to rotate your paper to see that better, you are always welcome to do so. Now, let's go ahead. If you wish, pause for a second. Now listen, the ultimate goal is to identify best value. In order to find the best value, you're going to want to find, you guessed it, a rate. So to find the rate or the value, we need to find the total cost and divide it by the volume. For instance, first one is $4.99, but we don't know the volume yet. Second one is $4.99, and we don't know the volume yet. So if you wish, pause the video, come on back when you're ready. Example 1 on the left, or maybe I should say example 3, I don't care what example you call it. Multiply pi times radius times height, where the radius is, of course, a measure of 3 inches, and the height is 9 inches tall. If you were to do that, you would find a volume of approximately 254 and 47 hundredths cubic inches. Onward to the left, where, whoa, mayday, mayday, alarm bells going off. Notice that 5 inches is not a radius. So we're going to have to take that 5 inches, we're going to have to split it up, divide it up into 2 parts to get a radius of 2.5. So we end up with pi times 2.5 times another 2.5 times 12. And when you multiply that, you would get 235 and 62 hundredths cubic inches. Now, dare I say, folks, that you should already and immediately know which one is a better value. Could we find the rate? Absolutely. By dividing $4.99 by each of these volumes, you will find a rate. But think about dividing a number by 2 different quantities. The bigger or more pieces you divide it into, the smaller it will take. So for instance, if I were to take $4.99 divided by 254 and 47 hundredths, it would be approximately, I'm going to say, instead of just going 1 penny, let's say, well, what if parts of pennies are important? So let me go a couple more digits. But ultimately, it's about 1 penny, actually closer to 2 pennies, huh? Now, let's say I do the same problem, but now instead of dividing by 254, we're going to divide by 235 and 62 hundredths. In this case, it's about 2 pennies. And yes, there are parts, but look, immediately you can tell if it's the same pop, we would rather pay less money per ounce. Or the other way to think about it, you pay the same amount, you get more volume pop. So the left side is the better deal. All right, ladies and gents, that's all I have for today. Onward to your homework assignment. Front page, fairly self-explanatory. You are welcome to rotate. Beware, beware, beware. If, say, you are ever given a diameter, you need to cut that diameter in half to find its radius. And make sure when you're using your formula that you always get 3 dimensions. Last but not least, as I directed in class yesterday, let's go ahead and cancel that out. We don't want to use 3 and 1400ths when we have a lovely option of pi, a pi button on our decimals calculator. Don't forget, when you do that decimals calculator, you may multiply pi times radius squared. You can either write times 6 times 11, or you could do the same thing, pi times 6, and you could use that power second squared button times 11. Please notice, same answer, 2 different ways of getting it. All right, folks, that's what I have. Take care, do well, and let's grow.